There you go. I am live. Hallelujah. That's very, very interesting. So this is 2 days in a row where I have not been able to start a stream with Twitch until after 5:30 a.m. Mountain Time. That's very, correlation is not causation, but that is an extremely correlated event at this point. So either, and this doesn't seem to be the case because I was looking at the log of Wirecast, and Wirecast gets connected to Twitch. It negotiates, it sends keyframe data, and then Twitch bails. They disconnect. Now, I don't know if it's a situation where, like I'm trying to stream at a higher bit rate. I'm trying to stream at 5 megabits per second. So it could be the case that it is for gamers, right? So, and I assume a lot of people stream, you know, are streaming at this time of the day around the world, and I'm trying to ask for a 5 megabit stream, and I don't know, maybe it's the case that Twitch just doesn't have it, or you know, they have a policy or something that says nope, not gonna let that go. But it does seem it's weird that it's so, like, it's the time literally around 5:30. It's like it's used to be, I'd occasionally have trouble getting connected around 5 a.m. my time, but not often. Now it's like it's moved to 5:30, and if I try before that, it doesn't work. And I was going to try to stream earlier this morning. Yeah, just really bizarre, kind of frustrating. Because like I said, I had a meeting crop up the other day for this morning. It's 8:30 a.m. for me this morning, and so I'm like, okay, well, I'll start streaming. I'll see if I can get online easier earlier in the morning. But then also, you know, I'll start earlier so I can still get about 4.5 hours in. But yeah, nothing. The internet was not going to cooperate with me, whether it's Twitch or my ISP or a combination of both. But I do think it's probably load related because, yeah. So let me just, actually save does work, I tested that. And I'll do a recap of what I did yesterday, and we'll start the stream fresh. But let me just try something here. So what uh-oh. Parser's not happy with that. Oh, interesting. Huh. Okay, well, so here's what we got. So I have some stuff in flight here because I was waiting to get connected. Let me go over what I did last night, and then we will pick up. And before I do that, I'll do my obligatory welcome. This is the nybbles.io daily programming stream. I'm Jeff. I typically try to stream Monday through Friday, 5 a.m. Mountain Time to 10 a.m. Mountain Time. Monday through Thursday, we work on the Ryu project, and on Fridays, we do something different. This week, we are going to be continuing to work on the Raspberry Pi arcade kernel, written in 100% ARM assembly. So that should be good. Hopefully, I'm able to start my stream on time tomorrow. We'll see about that. Morning. So with that intro out of the way, what did I do last night? So what I did last night was a couple things. First, so let me show you what it looks like when I run it first, and then we'll talk about the implementation. Because it'll just be easier if you see it. So first off, you're going to notice that the console is now taking up the whole screen, and that is now controllable. So you'll see a little gray tab over on the right. That's where the emulator's at right now. And for now, I have Alt F1 and Alt F2 set up. So Alt F1 controls the console size. So you can expand it and collapse the console. And then Alt F2 controls the emulator, and you can expand and collapse the emulator. So now we don't have to fight with screen size as much as we have been. I finally bit the bullet and said, you know what, we need to fix that because it's driving me nuts. So the great thing is now, you know, we have lots of space plus, so I'm going to collapse the, I'm going to split the console and the emulator for a second. The console is now a full virtual document. What does that mean? That means we can scroll left and right. So if I run help, you'll notice that things aren't getting, I can scroll over and I can see what's missing, right? So the document, the console document is 128 characters wide by up to 4K lines tall before it starts dropping things off the top. So it's got quite a scroll back history in it. We already had the scroll back stuff, but I implemented the horizontal virtual part of this. And so the status line in the bottom now shows the column indicator, the row indicator. The X and the Y are just the cursor limits, right? So the cursor limit here is 79 characters, but our document can go all the way over to a wider value. So that's really nice. And then of course, if we're not using the emulator, we can shrink that and then see everything. So I implemented that, and then we'll talk about what all I had to do to get that to work. So that was a big thing I did last night, was getting those changes made. And that required, you know, some refactoring and adjustment because I hadn't visited some of that code in the core plumbing of the UI in a while. And these tabs that I have here, these are placeholders. Either I'm going to get some bitmaps, or I don't know. I would like to have, I'll probably use bitmaps here. Right now I'm drawing it with a Polygon routine I wrote, just to have something to kind of indicate, hey, this is where I'm going. So that's programmer art. We're going to replace that, make it look nicer, but that's the idea. The state of the tabs is saved in preferences and reloaded from preferences. Hey, World Sender. Oh, cool. You have to show me an example of what your context-free grammar looks like. I'm doing okay. I'm a little miffed, frustrated this morning because it's the second day in a row that I've tried to start a stream, you know, and I can't get it started on time. And I don't change anything on my side, guys. Honest to God, I just let Wirecast keep trying to connect. And around 5:30 a.m. the past 3 days, local time, I get connected. But anything before that, and it's like all the Twitch servers, I can see in the log, I get connected and they negotiate, and then Twitch says, fuck off. And then it gets dropped. So I have no idea why that's happening. It's very, very annoying. So anyway, but other than that, I'm okay. So let's look at what I did last night for the UI stuff. So where should I start? Probably should start in context. So again, let me briefly explain the concepts here. So we have a window, and that window is being managed by SDL. So SDL is our platform independent windowing audio layer that we're using. And what am I trying to say here? Yes, so we have one main SDL window, and inside of that window, we subdivide that, and that subdivision is called a context. Within a context, so a context has bounds, so it's like a virtual window, if you will. And in what you saw there where I just added those tabs, that's like the very beginning of me building Chrome around our virtual windows, if you will. So a context has what I call a state stack. A state is it's a little state machine, right? In the places that implement state, I call them controllers, because that's kind of what they are. But more generically, the context just sees it as a stack of states, and so you can push new states onto the stack and you can pop stuff off the stack, and whatever state is on the top of the stack, that's the one that has focus, that's the one that gets events, and is being drawn. And then there's configuration options that you can set on a state as to whether or not that state is overlapping everything in an opaque way, or if it allows, like if it's a pop-up and it allows other things behind it to render, you know, kind of using like the painter's algorithm, right? So the states below the current state will render, and then the active state will render on top of it. If it's completely opaque and covers all the other states, then we don't bother trying to render those. So that kind of explains at a really high level what a context is. Off of the context, we have a blackboard. So yesterday we talked about patterns. So the context implements the blackboard pattern. So that allows code to arbitrarily put key value pairs into context, and then other parts of the system can look at that data or add data. So it's a way for these things to kind of inter-context communicate with each other. The context also has the palette that hangs off of it. So your palette, because that, if you think about it, and so I don't know if I've ever mentioned this, but because of the nature of what we're doing with Ryu, the rendering implementation is all palette driven. Even though technically SDL doesn't know anything about palettes, I built the interface for everything that way. A context has a default foreground and background color, and that's what it uses to fill the area that you see, and the cursor and any other views that are being drawn underneath the context. They can choose whatever color they want to use. They can, typically the default is to pick the foreground color of the context, but they can change that if they want. And then the context has a pointer to the font face and a pointer to the font family that is the default for it. And also has a pointer to the engine that is owning the context. So you have an engine class. An engine has contexts, and a context has then, you know, states, and states can then do what they want, right? States essentially have an on update, they have an on draw, they have an on process event, and I have a kind of a parallel view framework. And when I say view, I mean kind of like Visual Basic Control idea. It's a rectangle. It's similar. It has an on update, has an on draw. However, it's kind of, some of that stuff's abstracted a little bit, so it's easy to compose them. And then I've got views that are panels that will lay things out, and I've got views that, what am I trying to say here? Views that do text boxes, views that do drop downs, views that do tab windows, and they all look very primitive right now. And the text editor, the console editor, those are views as well. But a state can choose to render or not render views. It can do things manually. It has a reference to a renderer. So that, at a very high level, is what's happening here. So what I did yesterday was I refactored context a bit. So first, on the context side, I used to use a queue to bottle up the SDL events. So the engine is running in a loop. And actually, you know what? So let's look at engine real quick. It just might make sense to walk from the top down. Cool, awesome. Is your, hey World Center, is your code on GitHub, or is it just a local project you're working on? Okay, so back to where it was. All right, so engine, there's a bunch of setup stuff here, but we're gonna talk about the main loop, right? This is the thing that's running the game, running the engine. So we set up some stuff for time tracking and all that good stuff. SDL, if you want to do like text field type processing, where it has a buffer, internal buffer of keystrokes, you have to tell it to start text input mode. This is kind of interesting. Eventually, this probably should move to a slightly different spot in the plumbing, but that's an aside. I wrapped up all the SDL rendering into a class called renderer, and I pass in the pointer to the SDL renderer for the surface that we're rendering to. At some point, and probably next week when we start doing UI stuff, I would like to wrap up the SDL event stuff and not spew the SDL event structure down into the children. But right now, the SDL event is exposed all the way down the stack, right? And I, like I said, I would like to fix that. So we have a big loop. While the quit flag is not set, we update the timer pool, right? So we have these, we can create timers and they can do callbacks. So we just tick that over every time we loop. We do our delta time and we do our frames per second computation. We set the default color. So SDL is stateful. So you have a surface that you're rendering to, and you can set state on it, right? So you set what color the active color is, you can set what the active blend mode is, and all that stuff. And then we clear the surface, so that's what fills it. So initially it comes out black. And then what we do is so an event list, so what I did was I switched from a queue to just a vector, a standard vector. And the reason for that is how I'm gonna process it down this stack a little bit. But what we do is in the engine, we loop through the SDL events, we pull them, and we do some special handling for window type stuff because that's kind of at the engine level. That's not stuff we want to push down. So we kind of slurp those things up and handle them. If we got a quit event from SDL, we mark the quit flag, we loop, the while loop will then exit. Otherwise, we add whatever SDL event we got, key push, mouse click, joystick event, whatever, we push that into the list. Then we loop through the context that the engine has in it. So you have an engine, you create your context, you add those contexts to the engine, and then the engine, for every loop through the frame loop, calls update on that context. Then we loop, this is the stuff I added. So before last night, context did not have the ability to render themselves. They didn't have a draw on them. But as I started thinking about how I was going to do this, you know, Chrome on the context for like sizing and resizing and stuff like that, I realized, well, that's not going to work. I need an ability for the context to be able to draw stuff. And so I implemented that. And so within engine, so now we talked about engine. So I added some helper functions, raise, move, and raise, resize, because other parts of the system need to be able to tell the engine, hey, resize yourself, hey, move yourself. And then I also added a function, find context by name. So in the map, contexts are tracked by their ID. They come from the ID pool, but they also get a name. So in other parts of the system, we now have, like, this context might want to tell this other context, hey, do this thing. So I added that ability, and then if we look at the implementation, so raise, move, this is just if we have a move callback, then we do it. If raise, resize, if we have a resize callback, we do it, and we pass in the rect that is the size of the window, right? So we're telling everything underneath us, this is how big the total area is, now figure out how you should size yourself within that. And then I changed the queue to the list, and then here's where I changed, this used to be in line, so now it just calls those raise functions itself. I also added a default here just because CLion keeps reminding me that my switch statement's open-ended, and so I added that in here. And then I loop through here. This is, we talked about this, not this line here, but these. This now allows the context to draw when it's all the processing's done, everything inside the context and below has been rendered, and all those components have been given a chance to deal with the input. And so then at this point, the context can draw whatever it wants to draw. And the context is not bounded by the clip rect. So in other words, in here, when we get down into this, you'll see where we set a clip rect in the surface, in the renderer for SDL, which then causes everything to be, any draws that happen outside of that, they get clipped. Well, the clip rect is all reset at this point. It's been popped off. And so any drawing we do here, it's in the context of the entire window. Context classes kind of can cheat, and they can render wherever they want to render. Then I implemented the find context, and this just loops through and matches the name and returns back the new context. So now that we've looked at engine and we look at context, so then instead of passing in the queue reference, now I pass in the list. And then I did a little bit of shuffling here. Excuse me. I had to add a name accessor because we didn't have it. I added the draw public interface, and then I added the protected OnDraw and also on process event. So now context can also get a shot at processing events that are coming from the event queue. So Then we take a look at the header here, or not the header, the implementation file. And so here's a big change that I made. So I pass in the list now of events. What I used to do, so let's look at the left side. What I used to do is I used to say, hey, is there a current state for this context? Because again, a context has a state stack. A state stack is a stack of little state machines, okay? And only one of them is on top at the time. So whoever is the top of the stack, that's who's active, that's who's processing. And if you think about it with UIs for like pop-ups and stuff, that's why it works that way. Because then it's easy to like open up an editor, open up a dialog, pop, you know, and you can just quickly move back and forth that way. So it kind of creates a little structure around how that works navigationally. And then if I had a current state, then I would look at the top of the state stack. And then if the engine is, or if this context is focused, so that's the other thing, you tell the engine this is the context that's active right now, then I would loop through and process events. Well, that was kind of brain dead. So what I had to do instead was, oh, and the other thing here too is this code down here it was eliminating the events, right? So it was popping them off the stack. And so then this context, if it or any of its children slurped up events, then no peer context could ever see them, right? And that wasn't what I ever intended. So instead, I switched this. So I grabbed the beginning iterator on the events list, and I loop until we hit the end. And then inside here, I say, okay, if the engine is focused on this context and there's something at the top of the state stack that is valid, then go ahead and process that, you know, state stack entry and let it try to do whatever it's going to do. It sets the process flag whether or not it consumed that event, okay? If it didn't, and the context answered that event, then we erase the event from the queue. Otherwise, we go on to the next event. And so this allows now, if I do an Alt F1 and the, you know, the IDE context recognizes that, then it removes it from the queue. But all the children are also given an opportunity to deal with that. And if not, then that event goes over to the next context, and the next context, and so on and so forth. And then I did a little bit of shuffling here, and then added the draw, public draw, which all that does is call OnDraw, and the default OnDraw is a no-op, it doesn't do anything. And these were just shuffling of that around. So that refactoring there opened up the ability for me to implement that tab controlling stuff that we just saw. And then in core types, I added this, so I added the type def for the event list. And then I also added this enum for context window sizes. So our context windows can be split, they can be expanded, or they can be collapsed. And the two of them kind of cooperate with each other right now, and I'll show you what that means. For my poly renderer, I also added a vertex, 2D vertex struct. I added a span struct, which I ended up not using in the implementation, but I'm going to leave it in there because I could probably use it in the future. And then on preferences, I just added, you know, all the CRUD stuff here to, or not CRUD, just accessors and modifiers for the sizes. So we have an IDE window size, we have an emulator window size. They default to split. So the first time you run the app, they're going to be split, and then you can change the size as much as you want, and it saves the state after that. And then the implementation, there's two parts to this. The save, so we already had a window parent node in the YAML file that has the left top width and height and full screen flag for the overall window. And I figured that the IDE window and emulator window size was a good place to put those. So I just emit the numeric value of the enum here, and then down here in the load code, check to see if we have those, and if we do, I just cast them back to the enum value, and away we go. And then down here, these are just the accessors and mutators for those new things. In renderer, so this, I added fill polygon, and again, this is probably not going to be what we leave in here for the final implementation. It probably just will be easier to create bitmaps that we stick in there for the tabs, but for now, I didn't find anything I really liked on Google Images. So I implemented a Polygon fill routine, because SDL doesn't have anything like that out of the box. So that I have that vertex type, I have a list of those come in. If we don't have at least 3 points to make a triangle, then we bail. Otherwise, then we just need to find what our min and max Y is out of all of our points, right? So we need to know what the top and bottom bounds are. And then from there, we loop from the top bound to the bottom bound on the Y. And then we create a list of points that we're gonna sort, and then we're gonna pull apart and render. And so this code just goes through, right, and figures out for the given Y, what's the X and the Y, or the X1 and X2 for the span, right? Because we're going to draw a bunch of horizontal lines to fill the polygon. And this is, some black magic here that takes the Y, I guess you could say, slope's not the right word, but the Y point and the X point, combines them and puts them into our points list so that we can sort them very easily. And then we just loop through the points 2 at a time. So one point is the min X, the second point is the max X, and then we draw a horizontal line at the Y for min to max X. And so that fills our polygon. And that's how those tabs are being drawn. And then in Emulator Context, I had again, some of this code is close to the original that I had. So I moved this. Well, I didn't move it. I actually just got rid of it because we have another structure that has all this information, so this was kind of duplicate. And then I added the size accessor and size mutator for the Emulator Context. And then I implemented the OnDraw and OnProcess event. And then the Emulator Context keeps track of its current context window size. Now, then in the implementation, I shuffled some stuff around. I added some color definitions in here that I didn't have to make things consistent with the IDE context. So then in OnDraw, this is what actually is drawing the tab. So for the Emulator tab, we actually draw into the space of the IDE, and it matches the color scheme of the emulator, and the IDE is the opposite. It actually draws a tab into the emulator space using its color scheme. But if the emulator is expanded, then we don't bother drawing a tab because we already have expanded it. And then I just have some constants here. So the width of the tab, the slope of the little angle thing, and then the height. And then I grab the bounds of our context, which at this point is actually the whole window. I figure out roughly where the middle is with some slop in there for how I want to make it look. And then I create my vertice array that just basically draws, it's like from here to here to here to here to here, right? That's what draws the tab. And then I set the color, because again, the surface is, the renderer in SDL is stateful. So I set the color, I fill the polygon, I draw a line on the outline of it just to make the tab stick out a bit more. So then I set the color to black and I draw that black outline. Then this is new. I implemented on process event in this context. So we checked whether or not the Alt key has been pressed. And then if we have a key down event from SDL, and we come down here if it was F2 and the Alt key was down, then this is where I added that find context by name. I need to grab the IDE context, and yes, this is evil downcasting, but unfortunately necessary in this scenario. And then I look at the size of what the emulator is. So if it's split, then we're going to expand it, and we're going to shrink the IDE. And then if the emulator context is expanded or collapsed, then we're going to move it back to split, and then we're going to tell the IDE to split. And so that's how the sizing cooperation works between the two of those. And then these are just the accessor and mutator for the size on the context. The only kind of unique thing here is that the resize, I have to call resize on the engine to tell the engine, hey, kick off this callback if you have it, so that everybody is told, hey, you should update your size. And this parent resize, this is that resize method. So we check what size we are, and then we set our bounds according to which size mode we are. The IDE the IDE context is the exact same. I added the size accessor mutator, implemented OnDraw on process event, added the field for the size. And then in the implementation, some shuffling, because I'm obsessive about it. And then in OnDraw, same thing. If the context is already expanded, we don't bother to draw the tab. This draws the flip side, right? One is on the right edge and out, one is on the left edge and to the left of that. So they're kind of mirror images of each other, but they do the same thing. And then the event processing in the IDE context is the same, right? Is the Alt key down, was it F1? We get our emulator here, and then we check, is it split, then make it expanded, tell the emulator to shrink. If it's expanded or collapsed, then go back to the split size. And then we have the mutator for the size, and again, it calls resize on the engine, so he can then call the callback and tell everybody else to go do stuff. And then based on what our size is, this sets the context bounds properly. And then in application's the entry class. So main does nothing, right? All main does is create an application call, run on it. So I had to add the code in shutdown to save out our IDE window size and emulator window size to the preferences. And then down here, I have to, when the thing is initialized, right? So configure IDE, configure emulator get called when it initializes. We get the preferences read in. I have to take what's in the preferences and set it on the IDE context and on the emulator context. And I changed the constant that's being used here so that the emulator and the IDE use the same color index constant. The callback didn't change. This is that callback I was talking about for resizing. So the application kind of knows the composition of everything. And so on engine, we have an on resize callback that this goes to the topmost entry point in our system that kind of knows, this is the God entry point, right? He knows everything. So here, we know there's an IDE context, we know there's an emulator context, and so we call parent resize on those so that everything sets up the way that it's supposed to. So that was round one, and that gives us that ability to control sizes. The next thing I did was implement the horizontal scrolling on the console. Now, the functionality to support the scrolling was already there, right? The source text editor already does it. It's just that in console, I had intentionally not added support for it. So in document, I fixed some stupidity from early on that I had where I was trying to do crazy stuff with unsigned. And I just, so the current row and the current column are just signed values because that makes life easier for that scenario. And then I modified the clamp column to be signed because that just works so much better. And then the fields are signed. So this is the row that you're on. This is the column that you're on in the document. And then in the implementation, again, I was trying to do some weird wraparound stuff. I just fixed that. So now I just check to see, hey, if we're at the top, we're at the top. Otherwise, we check the bottom. Same thing for the scrolling. I didn't need to compute what the last column was and pass it in. Same thing with scroll right, that gets simplified. The accessor for row changes and the accessor for column changes. Again, the clamp doesn't need to be as complicated as it was. And then here's the clamp column. You know, again, just if it's less than 0, we stay there. Otherwise, you know, we check the maximum condition, and that's that. And so for document, those were kind of bug fixes. Then in text editor, because, okay, so this is console, I had already done this, but I hadn't propagated the change to text editor yet. So in console, I had refactored to where there was only one callback. So the owner of the text editor, or the owner of the console view, they can put a callback on there that says, hey, when the cursor changes, when the caret changes or the document changes, tell me about it. And so what I had done in console is I had consolidated those into caret changed, and you just get a reference to the caret, you get a reference to the document. So it's one call instead of two, and you get all the data that you need in the callback. So I got rid of the on document changed, and I got rid of the field for that callback, and that simplified that, and now the interface there is the same between those. And then I just added initializers for these, so the warning would go away. And then in the implementation, you know, our raise caret changed handler, it just passes the document reference, which we already had, but before we had two separate callbacks, which was kind of silly. Some casting got introduced because some things were changed from signed to unsigned, and but other than that, for the most part, in text editor, which is not the thing that's running in the console, but they're very similar. And then the document just calls raise caret changed and caret on caret changed. So this is the caret view. So that little teeny tiny little blinky thing, that's a view, and that has an event on it that gets raised whenever the caret changes state. So we just call this our aggregate, you know, raise caret changed. Same thing with the document. Whenever the document, we change the column, we change the row, whatever we do, that causes a change event, and then we percolate that up. Yeah, and then we got rid of the on document changed. And then in console, so I did learn some new stuff about some of the bugs that I've noticed over the past few days. So we did implement the full document support. And what's the format table bugs, actually I discovered are when we enable style codes, meaning that we go through the formatter and we get formatted line of T rows, then there's some bugs in that particular part of the code. So next week we'll be fixing that stuff. So then for caret end in the console, before, caret end would just go to the edge of the window, not the edge of the document. So I changed caret end to do the edge of the document, just like the text editor. Same thing, caret home used to just go to the leftmost edge of the window, not the document, right? So if you scroll all the way over to the right, now if you hit home, it will scroll the document and move the cursor to the far left side. Some casting again because some types changed. And then, okay, so before, when you did caret left in the console, if you were on the leftmost edge and you hit the left key, it would just go up a line and go to the end of the line. And then theoretically, if you just kept hitting left, it would scroll all the way up to the top, right? Now what happens is if you hit caret left, it moves the caret left. It also, if that overflows, meaning that you hit the left edge and the document is, not aligned to the very leftmost, it will scroll the document to the left. And then finally, if we've reached the left edge of the document, then we move the caret up and we go to the end of the next line. And caret right is the opposite, right? If we hit the rightmost edge of the window, then we try to scroll the document to the right. And then if we hit the very most edge of the document, then we go down the line and we go all the way back to the leftmost edge. And then I had to refactor the draw for console a little bit because before it was not considering the column within the start column and the end column within the document, right? Because we weren't allowing that horizontal scrolling. So I had to get those out. And then when we do the get line chunks out of the document, that we're telling it, hey, this is the column that we see on the leftmost edge. This is our rightmost edge. Can you give us that part? And I added some lines here just because at the time I thought it looked nicer. Okay, and then scale columns. This is the part that takes our data table structure and attempts to, because before, right, whatever size of that window was, we had to try to like shrink it down so that it would fit. But now we have a virtual document that's bigger than the window. So here we take the number of columns that the document has, which is, minimally 128. If you go beyond that bound, the document will resize, but minimally 128. So we knock 10 columns off that just so that we're not like butting right up against the rightmost edge. But in general, like this code, we're going to keep it, but it doesn't do much anymore because we have plenty of space at this point. I only do the copy on the string here if needed. I refactored that. Instead of always doing it, I just made it a conditional here. Our alignment issues live here, so we're going to have to figure that out next week. And then, I added defaults here for some of these. I just saw warnings in the code, so I tried to clean those up. So those are the changes to support scrolling in the console. Then the assembly listing, I cleaned this guy up a little bit because I wanted it to be, now that I had a bunch of space, I wanted it to be as readable as it could be. So our format line helper function is now format rows because that name matches better with what we're doing. And it returns back an array of rows, not just one. And I'll show you why that is. And then inside of the assembly listing implementation, I adjusted our column sizes again because now we have plenty of space. So it just makes sense to use it, right? So sorry, I restart some music here. Forgot about that. Yeah, so now we have 75 columns of source space. I mean, it's much more suitable for what we're doing. So what happens now is we call format rows. We get back a list of rows, and we have to loop through those and add them into our table. We can't just, it's not just one row. It's not one-to-one. Format rows could give you one row. It could give you 20 rows. It just depends. And so then the only other semantic change there is that in the actual annotate line, the number of annotated line count is incremented now by the size of the number of rows that come back, because those are rows that are valid rows. And I was playing with formatting here and trying to understand like where the issues were in the table formatting. So I added some padded strings in here just for testing purposes. I took some of the formatting stuff out temporarily. We're gonna put all that back in next week. But I was trying to figure out where the issues were in the formatting. And so then in our format rows, which used to be format line, what we do now is we create a vector of rows, and then we do what we were doing before for the most part. The only difference for some of this is that I added padding, right? So if there are no flags, you get a padded column, or padded address rather. Same thing, if there's no opcodes, you get a padded column. Now, the opcode / data. So to get that data, if you have a data definition and it's defining more than 8 bytes per row, we want that to wrap cleanly, and we want the address to increment as we go along for that. So what I did was I first format, if we have opcodes, I first format the 8 of them. If there's less than 8, that's okay. And for the flags, I do a padded string now, and I just put the character in the right spot. For the source line, I added the padding in. Again, we'll probably take the padding out once we fix some of this other stuff, but for now, I've left it in there. Then I have this concept of an overflow row. So this is a helper function that generates an overflow row for us, which is just gonna be the address and the data string, the opcode or data strings. And then I added a C flag to kind of indicate continuation in the output listing. Then at the very end, we say, okay, at index 8, we create a new stream and we increment the address, right? Because we know we already put 8 bytes out there. We're gonna overflow. We loop through any remaining opcodes. We format those, and then on boundaries of 8 of them, we create a new row and we format it out and we increment the address by 8. And then we just keep doing that until we hit the end, and then as a final, if we didn't hit an even 8 at the end, we dump out that very last row. And so then that returns back that list of rows to the annotator line function, and then it dumps those lines in. And so that fixed a lot of formatting issues in the assembly listing. In the evaluator, I discovered a bug, a subtle bug. So I was looking at the assembly listing and looking at it and trying to fix it. And so I realized that the address wasn't, on one of the data lines, the address didn't make sense to me. Like I saw, B018, and then I saw B019 on the next line. I'm like, that doesn't make sense. Plus I was looking at the line and I'm like, well, the addresses weren't making sense to me. And I realized what was going on was we were showing when we were adding the line annotation at the end, we were showing the location counter after we had inserted everything. When in reality for the line, we want to show the location counter before we started adding data. So here I just grab a local variable of the location counter before we start assembling the data into memory. And then at the very end, when we annotate the line, the address that gets passed in was that beginning address, not the end of the line address. So that actually fixed that, and now it makes total sense for what it should be. And then in environment, I went through for the symbol table and for help, and I just increased the column sizes because now we can afford to use a lot more space. And so that's what I did there. And then in the controller for the console, I added in the column information for the footer, right? So now we get the status information and we have virtual column that we should track. So the X and the Y are literally just the X and the Y of the cursor, and those are bounded to the window. And then these are bounded to the document. And so I did that. And then because I refactored the text editor and changed the interface. So we used to have an onDocument and an onCaret. So we were firing 2 callbacks. I consolidated those down into the one. And then I also changed the source editor, the text editor, to behave the same as the console, so that the column and the row are the document. It's the virtual row and it's the virtual column, right? So it's the document row plus the Caret row. It's the document column plus the Caret column. So mentally, when you're looking at it, you see, oh, I'm at row 120, right? And you are at row 120. As where before, you would have, the way I had it in the text editor, you would have to do some mental math, right? To say, oh, this is where I'm actually at. So I fixed that. And so that was the second one that I did. And then this morning, as I was waiting for the stream to start, boy vey, I started on our list from yesterday. So if we go back to our list, what was it? It was assembler parser, yeah. Okay, so our list for today was the uninitialized location counter, binary include local loop, and dupe. I also added to this list because I realized it's just going to make life easier. The paste operator and the quote operator. So I started thinking about this while I was waiting for the stream to connect, and so I started looking at what I needed to change. So one of the things I needed to do was I need to be able to, so we have this base class. We have parser, and this is a very generic, implements the plumbing and the main operational model of the parser itself. So this has the shunting yard stuff in it. It has like the air stuff and moving around in the token stream and all that good stuff, okay? So, and it has our standards, you know, standard parsers. It has parsers for the operators, the numbers, comments, expressions, identifiers, you name it. So I have a dictionary called operator dict, which is a string key and an operator T struct value. And then if we look at the implementation file for parser, these are the default operators for the core parser. And as you can see, I mean, we have a fair number, right? We have, you know, binary invert, we have negate, logical not, power, multiply, divide, modulo, add, subtract, binary add and or, and all that good stuff, right? We have our relational operators, we have our logical operators, and we have our grouping operators. So I started thinking, okay, I need to be able to add operators to the parser because I have subclasses now. I have the command parser, I have the assembler parser. So I want to be able to, when those classes start up, I want to be able to add these new operators. So I did a little bit of shuffling, and then I added this register operator on parser, and with the idea being that, this was just shuffling, that implementers of parser can now register new operators. So you pass in the key, you pass in your operator, and then we put it in the dictionary. That's all the base class does there. And then in the parser itself, the assembler parser, we have our new operators. So, so one of the changes I had to make, which is in this parser types, I made our op enum a uint16, and then I added a new group called conversion which we'll use that later in the evaluator. And then because now I have several different places that could be defining operator value, token values, I just switched this from the operator type because the enum in the assembler parser is not the same that's in the standard parser. So this is just now a numeric value that we cast. So that allowed that to be generic across those. And then in the assembler parser, we have dupe, quote, paste, and offset as our new operators. I didn't mention offset, so I should put that here. All right. So then in so I added a new function on assembler parser called register operators, which I just now realized I am not calling. So that's probably why my test earlier failed. So if I go to assembler, and I believe these are default. Did I not make it? There it is. Is it private? It's probably private. Yep. All right, so now we have this register operators call, and then the assembler, we call that, and it sets up. So now the parser has those new operators visible to it in the operator dictionary. And this is kind of where I had gotten to right around the, yes, this is a recursive descent parser, correct. Yep. So I think this is about as far as I'd gotten. Yeah, I added our new operators here. I forgot to make the call to actually to this new function, so I just added that, and then yeah, so that's where I got to. And so I added the call to that to register those, so let's test that again. Now there's a couple things. The dupe operator is a little bit of an oddball syntactically. Typically in assemblers, the right-hand side of the dupe operator is in parentheses. My little test right now, it isn't going to parse that way, although technically I guess it could. It would just see it as an expression, right? So I could do this, and it would just see that as an expression, but it has nothing to do with dupe syntactically. So for now, I'm going to leave that off because I don't want it to be, I don't want to be confused yet. But unknown binary operator group, interesting. Okay. And our annotated line is showing up. Oh, I know why. Yep, see, I refactor things, it breaks. It's awesome. That's easy to fix though. So Maybe it isn't what I thought. So let's figure out why that's not showing up where I expect it to be. Okay, so it's at line 17 is the line we're trying to annotate. So we annotate the actual, we call annotate line to actually annotate the assembly line. So we didn't have any catch up to do. We increment our current line. The row count that came out is actually 1. Oh. Yeah. That logic's wrong. Those are the source lines. Yeah, it's going to insert it before, because we've added the row. So if we take the row that we just added, so if we're less than what we just added, that was the scenario we were trying to cover there, not the currently added row. We want to exclude that from our logic. Go. There we go. Now it's in the right spot. But see, notice how, because this is formatted red, we're off by 1 here. That's why that's happening. This E would actually be in the right spot if, I think. Maybe not. Maybe that's just me. Maybe I did that wrong. Sorry, I'm getting stuck on minutia, I know it, but... some days the OCD, 1, 2, 3, 4, oh yeah, I am off by 1. All right. So it has nothing to do with the format code. That was just me being stupid. All right. So now we can go back to why it's not parsing it. So it's not recognizing the group, which is true. It is a different group. It's in the conversion group. There you go. Okay. So, all right, well, that's good. At least it's seeing it. And so now let's go to, that would be in the core parser. Unknown. Group? Maybe it isn't. Oh no. I think I know where it's coming from. I think it's coming from the evaluator. Because it's a binary operator. Dupe is a binary operator. Yeah. Yes. So it's hitting the default here, and it's saying I don't know what that is. Okay. So that makes sense. So that's what the conversion, the new group type is for here, is so that in the evaluator we can do stuff for it. And we may actually have to add a couple groups, I don't know. I just added the one for now. Because technically, like, at least the way I'm thinking about most of these new operators, that's what they are, right? Paste is a conversion operator, it concatenate. Quote is a conversion operator, it takes a symbol, whatever you pass it, and it puts quotes around it. You know, dupe is taking a count and a pattern, and it's repeating it. That's pretty much, I'm kind of considering those generically data conversion operators. So let's, after adding those to the evaluator so it doesn't choke on them, but there's still no ops, they don't do anything. I would just like to see how the, right, okay, so this is, now we're not choking on the fact that there's an operator it doesn't recognize anymore. It recognized it. The problem is that doesn't mean anything to the data directive. It's not a parameter list. It's not an expression. So it can't decompose it, but that's okay. That's a start. So let's also then, let's do a couple other things. Let's, because we don't have any of the code yet that does the macro expansion inline, so I'm trying to think of a interesting way to test some of the other operators. So this is the quote operator. Let's see, that's interesting. Yeah. Well, here's what we could do. Yeah, that should be okay, actually. Okay. So it's not complaining about the operator. It's just saying, I don't know what to do with this. Okay, so that being the case, let's put a breakpoint in here. So that we can see at least what the data looks like. So the quote operator is a unary operator, and the dupe is a binary. Okay, so here's our tick. So we're getting there. That's correct. The op is 501. It's a tick symbol. The precedence, the type, the associativity, the group. Perfect. That's what I wanted to see. And so then our right-hand side node should be a symbol. It should be an identifier. Oh, I didn't mean to do that. Oh, that's interesting. So the right-hand side is a numeric literal. Right? 0, 1. That I did not expect. Oh, well, but that's, why is that? Because okay, so the node that comes in before evaluate is an identifier. It's just evaluate is turning that identifier into a number for some reason, which shouldn't be happening, but okay. At least the data's there. We may have to refactor then how this is implemented. Yeah, because like lots of data, that's not one. I don't know why that's becoming one. Unless it's treating it as a Boolean expression for some reason, which I'm not sure why it would be, but yeah, that's a little bizarre. Oh, uh-oh. And I just know, oh, darn it. What did I do? Oh no, it's because we have an error, so it's stopping. All right, never mind. Like, why am I not seeing any addresses anywhere else? That's why. Okay. Yeah, and so I think paste and everything else is going to be very similar. We would just have to actually, so the parser is recognizing the symbols. So let's do this. Let's the chat window that you see on the screen is WeChat. Let's see here. No, it's WeChat's been around for a while. It's just a IRC client, and I don't know. I've always liked it. Thought it worked pretty good. I'm just changing the music selection here. Where's my radio station? All right, just looking for a link. I can't quite remember what it's called. So, oh, there it is. Got it. Ah, seriously? There it goes. Yay. Okay. If by functional programming you mean Lisp, Clojure, Scheme, Not much recently. I used to. There was a time back in the 90s when I had like a little, my own little Lisp runtime I had written in C, and I would just kind of embed it in everything that I built because it let me do like config files and stuff really easily. Yeah, I haven't done much with it recently. I'm a big fan of Forth. I wouldn't consider Forth functional, but it's kind of, in its own little category there. And I have also had the habit of embedding a Forth runtime in a lot of projects that I've used, again, because it's a great little configuration language, very powerful. So I like that. And I actually debated with Ryu, implementing a Forth for the console. And I don't know, we may still do that. I don't know. Because it would be cool to have like scripting ability beyond just being able to issue simple commands. But yeah, some of the newer stuff like Rust and, gosh, I've done some Scala work. I'm not a huge fan of it. Done some F# stuff. F# okay, not bad. But yeah, Haskell, I've read some documentation, I've looked at some code, not done anything with it, so. Yeah, once you've written some parsers, right? Like you say, it's a skill set that then sticks with you, and it becomes easier to do it in the future. And you can also start looking at things and saying, oh yeah, I could parse that, or that would be kind of tricky. All right. So what was I going to do? Oh yeah, I was just going to go back to the dupe. Dupe would be our first. The Dupinator. Oops, not in dupe. Here, there we go. Yeah, again, like Elixir, I've read some stuff about it. I've looked at it. I haven't really tried to use it very much. My experience in the past, and this is kind of, Clojure's good. I mean, Clojure got around a lot of this for me, but I used to, try to build things with Common Lisp or other variants of Lisp, and I just always got frustrated because, for better or worse, the world of software is mostly integrate with this other thing over here, and I always just ran into issues when it started getting into the integration story. But Yeah. Same thing with Smalltalk. I mean, that's kind of why I started, when systems move from the desktop to being distributed and more complex, and that those tool sets like Common Lisp and Smalltalk and a lot of those, they just struggled a little bit because their worldview was very different than what ended up becoming the thing. So yeah, Elixir is one of those languages that I don't know if it's just me, but it seemed like every time I read about it, it's somehow tied to web stuff, and so my bozo bit gets set pretty quickly, and I move past it. So I probably shouldn't do that, but that's what happens. So this would be quote. This would be paste. Quote, paste, and offset are our three unary operators. Best threads out there? As in multi-threading? I thought, well, yeah. Okay, now I'm curious. Oh, they have lightweight threads. They have fibers or coroutines. That's not multi-threading. That's a kind of cooperative multi-threading, but yeah. Yeah. So, I mean, again, this, like fibers, synthetic threads, they have their uses. Oh, this actually reminds me of Erlang, really. Actually, this exactly reminds me of Erlang. They borrowed the arity syntax from it and everything. Okay. So yeah, this is basically like Erlang. Oh, it's okay. So yeah, all right. Well then, I didn't know that. So now that I know that, I know Erlang, so okay, cool. I mean, Erlang's fine. But yeah, see, Erlang is, yeah, it's different, right? When you say threads, I think POSIX operating system threads. But in Erlang, that's not the case, right? They're separate processes that are communicating to, with each other. Okay, what was I doing? Okay, so I added my empty implementations. I've got an air condition for cases that aren't supported. So for the dupe, the way this works is the left-hand side is the count. It's the data count. And so actually, boy, this is, I really wanna, these switch statements are getting crazy. Stop. Come on, sea lion. Give up. Thank you. So this should be the count. And then the right-hand side is going to be what? It's not going to recognize a parameter list, I don't think, because that's not at the base parser level. So, okay. So this is then a question of what do we want to support? Yeah, World Sender's point is again, it depends on your goals. You know, if performance is really important for you, then things like Go channels and Erlang message sending is not going to be very. You're going to have lots of processes and very heavily distributed to get where you need to get. Now, with that said, Erlang has been used in the embedded space for a very long time, so it can be performant. But now you're having to kind of constantly work on all that to keep it where it needs to be. In terms of like real threading, real CPU level threads, nobody does that, right? I mean, that's just a case-by-case basis, and you have to know what you're doing. It's very much like, you know, riding a very fast and fancy motorcycle around very tight curves. If you know what you're doing, you're not going to fall. If you don't, you're going to die. So here's the interesting challenge with dupe. So dupe in most assemblers supports two modes. One is just a value, right? So this is going to put 5 C0s in memory starting at the current location counter. This is going to put the pair 2 and 8. So byte 2, byte 8, and that's going to happen 5 times because that's what can fit in 10. So our parser, though, cannot do this yet. Doesn't understand that. And just to satisfy myself that that's the case, I'm going to test this real quick, but I think it's the case. So we have a dupe here. Actually, I'm going to get rid of that. So we have a dupe here. This is the simple class O pattern, byte 10 dupe 2 4. Yeah, I don't think that's going to work. Oh, yep, no. Yeah, it got seriously messed up there. It hung. Mr. Tutti Frutti, hello. What do you think about working in Microsoft? Do you mean, just to clarify what you're asking, do you mean what do I think about working for Microsoft as a company, or do you mean what do I think about using Microsoft technologies like Visual Studio, C#, whatever, .NET, Visual Studio, or Visual C++? I'm assuming it's the latter, but I just want to clarify. Yeah, so this does not work right now. Oh, working for Microsoft? My experience with Microsoft, the company, I used to interact with people inside Microsoft frequently about 20 odd years, 25 years ago. So, you know, back when Bill G was still around and Ballmer, I think Microsoft has changed quite a bit, but I would think it would be kind of the same as most other companies in that at that size, right? So to me, give or take, Microsoft, Apple, Google, Facebook, Twitter, you know, any of those companies, I think working for them is going to be very similar. And to some extent, it's going to depend on what team you end up on. And who your boss is and who your teammates are. So yeah, it's hard to say, you know. I've known folks that have worked at Microsoft in the past, and some of them have been very happy with what they do, and some of them can't wait to find a different job. So yeah, it just all depends, I think, ultimately on what you're doing. And I think that's a true statement. When it comes to work, when working someplace, I think that's a true statement across the board, right? You have to be very diligent up front about what it is you're going to be doing, and, you know, make up your mind that you're going to be okay with that. And I'm tempted to go on a rant about Agile and how it's fucking over the software industry. Maybe if somebody votes for me to, you know, if somebody says in the chat that I should go on the rant, I will, but I'm going to try to hold my tongue. Yeah, okay, so that case we don't do. So we're going to skip that case for now. Because, yeah, that's just going to be a pain in the butt. We'll have to do it, but so we don't do this. Actually, you know what? Let's do it this way. Okay, TracerXDump has prompted me to go on my rant. Okay, let me see if I can do this without getting really hyped up. All the way back, just as color was coming into the universe in the late 1990s. Everything was mostly black and white before that. There was this guy, Ward Cunningham, who started this thing called WikiWiki. He had the C3 Portland Pattern Repository, that's what it stood for. And he started, or I think he invited his buddies. He invited Kent Beck and he invited Chet Hendrickson and a bunch of other guys. And they started posting stuff about this project, the Chrysler Comprehensive Compensation Project. And some of it was tech, some of it was, oh, we're using Smalltalk, we're using Envy, we're using Gemstone, you know. And then they started posting stuff on the wiki about this process that they had developed. And that became XP, that became extreme programming. Now, the important thing, the distinction, and this is always, these are the fuzzy details that are lost, right, to history, because the winners write the history. And unfortunately, in my opinion, what Agile was trying to be did not win. It lost. So, but the key point that I took away from all that stuff back in the day was that Kent and Ron had managed to convince Chrysler management there were no due dates. There was no, we have this deadline. Okay, so how do most projects work? Most projects work, they call you up and they say, we've already had all these meetings. My big boss, who's a senior executive VP, whoever, CIO guy, said this has to be done the 15th of next month. You have 30 days, or you have 60 days, or you have 90 days, or you have 6 months. That's what happens. Not what Agile would presuppose would happen, right? That you just, okay, we have to build this thing. We really have no idea how long it's going to take to do that. But what we'll do is we'll kind of identify things that we think we should do. We'll put them in a bucket. We'll call it a time box. We'll see how much of it we get done so that we can at least like kind of keep track of how fast we think we're going. And then we can at least kind of tell you roughly about what our productivity rate is in a given time box. But we still can't tell you that we're going to hit that deadline, right? So you have a new project, it's February the 1st, it's due at March 1st. Okay, that's not Agile. The only way in which that could be Agile is if you can aggressively control scope. But in every situation I've ever been in, they don't let you control scope, right? So there's the iron triangle, right? You know, quality, scope, and time. Pick two. Well, okay, so they pick time. If they want time and quality, right? If they want time and, you know, and time can be a proxy for cost too. If they want time and they want, you know, features, they want scope. Okay, so one of those two has to balance the other out. But no one's ever willing to negotiate on those things, right? And when I say no one, I mean a company that you engage with and they want a project and they're paying you. And by the time you get involved in the project, all these decisions have been made by marketing departments and sales departments and other layers of management and partner companies. And so here you come along and let's play Agile, right? And you have no control. So it's just fundamentally a mirage. It just doesn't exist. And you know, so I always approach project scheduling the exact same way. Tell me what your due date is. Tell me what the date is that 30 days before that date, you will start getting the, you know, whips and chains out and you will start flogging people and yelling and screaming at them. And believe me, guys, this happens, right? You hear the term death march, and until you've really been on one, you don't know what it's like. But I have grown to appreciate that when someone tells me this is their due date, that's their due date, right? And if you get close to it, you know, they will start really making your life miserable, right? And agile, to me, those two things do not mix. Having a fixed delivery date and agile, this concept of there's all this work to do, we have no idea how long it's really going to take to do the whole thing, but we can give you an update every week, or we can give you an update every 2 weeks and kind of tell you where we're at, and you can see continual progress. And when we get there, right? And that's agile. That's fundamentally agile. When we get there, we get there. You know, how much longer, Dad? No idea. When we get there, we get there, right? But see, companies don't work that way. They just don't. Even if your development shop inside of a company worked that way, the rest of the company doesn't work that way. Every other part of a company, the people who would pay to have software made, every other part has due dates, delivery dates. I need this by Tuesday. This has to be turned on by Wednesday next week, whatever. That's how everybody else works. So, yeah, agile. And what's happened, and this is the part that, okay, so that's why I think agile doesn't work. What really tweaks me though is we're now in this mode where everybody plays agile. We all pretend, right? And Scrum is the evil that perpetuated it, right? Because what did Scrum do? So extreme programming, it caught on a little, right? But it didn't catch on big time. Why didn't extreme programming catch on big time? It didn't catch on big time because it had technical practices built into it. It had technical constraints built into it. And management doesn't like that, right? That stuff pisses them off because you have to pair program, you have to unit test, you have to do all this stuff, right? They don't want that, right? Now, I'm not debating the veracity of TDD or any of that. Again, I think I did a rant on TDD last week. But my point is, whatever group of technical rules that you would have, this is how you should design software. This is how you should test it. This is how you should, address design and so on and so forth. Those things, they don't like any of that stuff because those things start putting rigor and structure around what you're really doing. But what they do love, because project managers can grab a hold of this and sell it, is they love the time boxing. And they love things like Jira. I mean, who here in chat has used Jira? The biggest piece of shit tool on the planet, and everybody uses it. It is horrible. And Jira, I don't care how much you customize it, Jira and Agile don't go together, right? You know what I see in stand-ups with people who use Jira? I see 20 minutes down the drain because somebody can't get a view to filter right in Jira, or Jira isn't doing what they want it to do. So they muck with the tool for 15 or 20 minutes instead of having a damn whiteboard with sticky notes on it and just saying, oh, did you do this? Did you do that? Here's the thing that just gets me, right? Here are our stories, right? Here's our board. This is so simple. Why does it have to be any more complex than that? Even if you have a group of developers, so anyway, what's happened is Scrum came along and said, well, selling all this stuff to companies is hard, with all these complex technical practices. So instead, let's just sell this concept of time boxing, and whatever happens inside that time box is, we don't really know. And it became a project management thing. So Yeah. In my experience in the past, I want to say, my goodness, the past 15-ish years, maybe a little less than that, Agile has resulted in just nothing but frustration and just mismatched expectations, because developers come to Agile and they read all the history stuff, right? They read all the books, and so they think that it should work the way it should work. And then you get into a company and they don't do it that way. So, and that becomes very, very disappointing. Okay. That end of rant. My Agile rant. My rant is Agile. It is. Okay, so here's where I'm kind of stuck on dupe. So here's the situation. We have this evaluator, right? So this is being evaluated in. This is not being evaluated in the pass1 transform. For the assembler, this is in the evaluator. You're welcome. I hope it helps. You know, again, there's not much you can do about it. Unfortunately, I think. But so, yeah, so here's the issue. The evaluator has to return back a variant. At least that's what it does today, right? What is a variant? A variant is, it's either a string or a number or a radix number, or, you know, it's one of our variant types. Now we could create a new variant type, so that's not, and that's probably what we're going to have to do. But I'm just talking through it so I can kind of wrap my head around what it is exactly we need to do. So, because what's going to happen here is we need to make a bunch of data, right? And it's not that we need to make a bunch of data, it's that we need to give back a variant to the transform that says, here's the count, here's the pattern, and then, you know, the rest of it can, the transformer can deal with it, right, at that point. So I guess where I'm angling to this is the evaluate method. His job is to take AST nodes and simplify them down to a variant value of some kind. So in order to do that for dupe, we're going to need a new variant value, and right. So, okay. Parser types. So we need a new one of these guys here called dupe literal T. And this guy has a count, which could be up to, I suppose, theoretically, 32 bits. And then it has a, see, this is where I'm kind of like stuck, is should the evaluate, I think the answer to this question is yes. I think what we end up with is like a standard vector of variant T, that are the values, but of course variant t doesn't exist yet. We knew that was going to happen, right? Because really what we would want is, for the dupe, we have the count, dupe, and a pattern. Now the parser doesn't do the pattern yet, but thinking ahead to the pattern, you know, what is that gonna look like when we decompose it down into a variant, right? And so I think the answer in my mind is it's going to look like, it would look something like this. It would be a list of the variants that, so we have the node for the left-hand side, we have the operator, and we have the operator node, I should say, and the left-hand side of that is the count, the right-hand side of that is a list of expressions that get decomposed into variants, and then we want to put those into this list. And then the transformer, the parser transformer, well actually, not the parser transformer. I think we probably would have to do it here, right? As part of the serializer. We'd have to implement a serializer for it that would take the values and format them properly based on what they are, right? All right, so let me think about this. Does it make sense? Let me actually look at a different parser or different assembler and just see, like, you know, see what they do here, because I might be making this too complex. Crap. And the very first example I find is is what I was thinking I wouldn't need. But at the same time, this could be okay. Okay, so this makes, we still, no. Because they still become, at the end of the day, they just become numbers, right? Yes. So, all right, so here's what I think I can say. I'm looking at other examples from other assemblers, and to avoid I don't think we have to have the complexity of a recursive list of variants. I mean, if we did, that would be like the most flexible, but this would work. So I'm looking at some examples, right? And so there's examples of characters. There's examples of bytes or words or D words. But it looks like most assemblers don't support duping anything but characters. They don't support duping of strings, and I certainly have never seen that. That doesn't mean it doesn't exist, it's not common. Here we go. This is the one I wanted to look at. Yeah, I mean, pretty much that's what I'm trying to boil it down to. I'm trying to boil it down to, you know, exactly what you say. I think the basics get us 99% of the way to where we need to be. So, okay, so here's what's going to happen. We're not going to, you cannot do a string as an argument to a dupe, but you can do a character because a character can be converted to a number. And you can do any other numeric values that we support. So you can do byte, word, D word. Those are all fine. Because those, we can decompose all those down to numeric literal T values. So then we get a count and we get a pattern list, which right now we're only going to have one value in the pattern list, but they will always be numbers. So, okay. So then in our variant, we add dupe literal T. Okay, oh, and as a reminder, so today I had some meetings come up late yesterday that I couldn't shuffle, unfortunately, out of my morning. Typically, I'm able to put things into the afternoon. So I have about an hour, a little less than an hour on the stream. I was gonna wrap up about 8:20-ish local time. So I have about another 45 minutes-ish of coding time. If you have questions, by all means, think about them and let me know. And maybe, you know, let's say about 10 after the next hour, if you have questions, shoot them out there and that'll give me some time to answer those. So then in our variant structure, we have to add our new type, and yeah, see, I never did implement that. Okay, so that takes care of that part. Hello, SP Sniper 1. Okay, so we have our new variant type that represents the data for a dupe. We put that in our variant template. We put it in our variant type wrapper helper thingamabob we have. Thingamabob. I'm getting real technical now. Okay, so then here so we're only going to ever have one value for now. Eventually we will support the parameter list, but so here actually we already have it because we've already reduced the right hand side. So so here I just say if right hand side node, which is equal to variant types numeric, or char. So we said we can do one of these, right? Let me just double check that in the evaluator. Yeah, so for character literal, we just return back the variant for that literal. So we have to pop it, or cast it down to what we want here. So actually, it is already a variant. So if it's not number or character, that's bad. That's an error. Otherwise, oh no, because it is a, darn it, I thought it was already. No, bad Jeff. Oh, I just thought of an idea. Sorry, I'm trying to find a way to do this without without having a bunch of conditional code. Numeric, literal, T. Operator. Let's see here. I always forget how to do these because I don't do them very frequently. Oh, that's right. Oh, okay. So this is correct. I just don't have an ordering problem here. So that, excuse me. Right, that's right. This just deals with this. right to me. Oh, there's no return type, that's right. Still not liking that. Oh, that's because I got the syntax wrong. Duh. See, I'll use a feature. Forget about it. I knew it was there. There we go. So now we have an implicit cast operator from a char key to a number literal. So then going back here, if it's not one of the two types that we support, that's an error. We need to handle that. Otherwise, we can just, do the number. Is that true? Well, it's true on the casting side. Ah, it's a stupid boost variant. The struggles. All right. See, this is the trap I fall into. I always try to find a way, while I'm coding it, I try to find a way to make it all nice and pretty. And I should just like rip it out and then worry about the nice and pretty later. So here, number literal, oops, how should I spell it right? No, it's numeric. There it is. And this is going to be, actually, that's what it is. So I'm going to do that. Finally. Okay. Okay, go away. Stop doing that. And then we do the same thing here. And I can, no. Variant won't like that, but that's okay. Because I can do this. So we have to know the type to get it out of the variant. Unfortunately, just the nature of that boost template. This is an error. That. Okay. Dupe. So we create our dupe literal t, and then our dupe literal values, push back. return okay, so let me think through this here. So we get the data count. That's the left-hand value of this binary operator. We create our dup literal t, our new structure. We pass in the data count. Then we check the right-hand value. Is it a numeric literal? Yes, it is. Okay, we have to get it out of the boost variant that way, and we put that in the values list of our dup literal. Otherwise, if it's a character, we have to get it out of the boost variant that way, because that's how it's identified. And we cast it, because we added that cast operator to, and actually, because it's implicit, I think that will just work. So let's see. Otherwise, we got a value type. We got something there that didn't match our expectations. So that's an error. And then otherwise, we return back our dup literal. That's what the dup conversion operator does. It creates that struct. And then other parts of the code are going to have to take that dup literal and turn it into something, which we'll have to handle, right? So in our data conversion, or our data definition directive, we're going to have to add in a check. Hey, is one of these parameters a dup? If it is, then do these things to it. Invalid operands to binary expression. Oh, I see. Yep. No, I understand now. Yeah, I was pretty sure that was the case, but okay, that's easy to fix. I can fix that. So what's happening here is we have this serialize, and it's trying to take the variant type that we use, and we have a case where it just generically says put this on a stream. So then, the compiler is like, well, there isn't something on that type to handle that scenario, so it's very unhappy. So to fix that, and I'm gonna just leave it a no op for now, because yeah, we'll figure that out. Extraneous. Parentheses. Yep. I'm going to take just like a 1 minute break here. I will be right back. And then all right, I lied. 3 minutes. Okay, I'm back. All right. All right, that compiled. So here is what I would expect to see. What I would expect to see is in our data directive, I would expect to see that value come through, right? So this should succeed, but we should end up down in here because it doesn't know how to handle that variant type yet. Uh-oh. Did I not? Now I'm confused. I thought I commented out. The offending syntax here. Maybe not. So these would just be coming out. Okay. We're definitely getting stuck somewhere. Parse identifier. All right, so what? Why is it doing that? No. That's a comment. Ah. So parse comment is not getting our comment? Okay, that's a problem. Okay, so now we gotta, why is that not working? So let's, yeah, that's not good. So we should get, that's the first comment. That's okay, that's okay, that's okay. Ah. It ate up the why did that happen? It ate up the comment character. Why is it doing that? Yeah, so what's happening is it's parsing this and then somehow it's eating up this. Oh, because it sees it as an expression. Okay. That I can fix. So this is this is eating the line, the new line. And that's, so in most assemblers, it's line oriented, it's not free form. And in most assemblers, to have a line break, like if we wanted to do a line break here, we would have to explicitly put like a backslash character in here for the assembler to support that. So that's okay. So the white space, yeah, see, it's, so if we hit a new line character, we need to increment the line, but we need to stop. So we hit a new line character, increment the line number, but then move to the next token and don't eat anymore. Yeah, that seems right. Because yeah, what was happening before is consume whitespace was just slurping up line feeds, new lines, and it was saying, oh, there's an asterisk. That must be, you know, FF times whatever. So yeah, that was bad. Okay. Yeah, still getting stuck somewhere. Okay, so we read. Okay, so this, there's no leading, no comment. So this should break, okay, so now we're at the comment. So that should be good. Oh, okay, there it goes. Yeah, so there are 2 comments. Now we're going to try to read the label. And we didn't read, well, we did. So where's it getting stuck? It's getting stuck there. The very last label. Okay. Why would that be? So let's, because it's towards the end of the character stream, there's probably an off by 1 situation here that we're not tackling. Of course, we subtly changed how, not porge, so we subtly changed how white space is being handled. Here we are. This the one? No, this one's okay. All right, here we go. So Why are there 2 colons at the end? Yeah, so see now, it's probably just stuck. There's this colon at the end. Extra colon. Where is that coming from? Ah! It's coming from my Vim. I accidentally hit a colon in insert mode. Oy vey. Yeah, so see, we need some kind of a, like in parse identifier, we need to say before we even start, so if we have a matching first character, if s is equal to this, then okay, I'm going to have to wrap up in the next 10 minutes or so. Oops. What's that? So if anybody has questions, you can shoot on those. And then we'll go through the code changes we made so far. I mean, the good news is the parser is recognizing, for the most part, our new operators. The evaluator is handling dupe partially. I have to figure out a way to enhance the parsing for custom operators. So that's going to be the next step to get dupe. No, still getting stuck. Huh. Yeah, the input is assembly code. Yeah, it's still hitting that case. So if we come in here, oh, I see. Yeah, there we go. It was actually setting, the output of this is raw binary machine code, basically. So the assembler is writing into the virtual memory of our machine, arcade machine. So I can kind of show you here really briefly. Okay, awesome. So just finishing this little thread here, this is exactly where I thought I would end up. I thought I would end up here because we have this dupe literal T and the data definition code doesn't know how to handle that. So that's good. So now we have data directive requires constant memory value. So this is not, this is exactly what I expected. So to finish the implementation here is not so bad at that point. So we can actually get that wired up later. But and then to the question about what this actually does. So here in the assembly listing, you can see the data that we're writing out, and then the origin statement here is at B000, which actually points at one of our virtual ROM chips for our machine. And so the H command does a dump of memory, and B000 is where we're writing to. So if I dump that, you can see that the assembler is, putting the values of the assembly process into our virtual memory space for our machine. So that's what it actually does. All right, so let's review this real quick. It's kind of half working, so I'm going to consider this a checkpoint. Okay, so in parser, yeah, we already talked about most of these. These were changes I made just before the stream started. In parser types, though, we added dupe literal to our variant. And let's see, where's our dupe? Yeah, we had to move char literal t, and then we created the dupe literal t that goes into our variants template. And a dupe has a count and a list of values that make up the pattern. We have a placeholder stream operator on here for serialization. We don't quite know what that's going to look like yet, so we'll come back to that. And then in the parser implementation file, again, we covered most of this. This was just refactoring I did prior to the stream. The only new thing that we have is in the parse identifier. I'm now trying to grab or trying to handle the case where there's an errant colon floating around that we didn't expect. And then I also changed the white space. Where's that at? Consume white space. So now consume white space is it doesn't just keep going and going and going. If it hits a new line, it increments the line number, we move to the next token, and we break. That's as far as we go. That prevents, like, if you start an expression and then you try to continue it on a line, eventually we'll add an explicit line break operator, but for now, we don't really need that. And then in Evaluator, we added the whole new group to binary operator and unary operator for our conversion operators for the assembler. And we got, a very basic initial cut of the dupe implementation here. There's more that has to be done here, but this is, structurally this is very close to what it needs to be. And then I've got placeholders for the other operators, and they're going to follow a very similar pattern. And then in assembly listing, I had a bug when I was inserting the error row. It was off by 1. In assembly parser, I made some notes about what changed here in our scope. And yeah, these are things that we did earlier. Unfortunately, had I been able to get going on time today, we might have been able to get a little bit further along. Maybe not. But yeah, I kind of feel slightly dejected that I didn't get as much done as I wanted to. But that's like, always seems to be the case. And then there, I was not checking the error state of the assembler, right? So if the assembler is in an error state, then we should bail because we have code that sets errors, but the token may not necessarily be null, right? So it's really, should we bail is, do we have a token or are we in a failed state? And if we're in a failed state, then we should bail. And in assembler, I made the constructor non-default so that it can call the register operators on parser. And so that's about as far as we got today, which is not bad, I guess, but again, I wish I checkpoint 1 operator implementation. Do partially works. Placeholders. Operators. Okay, so some housekeeping notes. I only got a couple hours in, I think, today, unfortunately, which is really a shame. Yeah, almost 3 hours, I guess. But so I'm going to say that maybe I might do another stream later this afternoon because I hate not making progress. And the reason I didn't make progress is not because, you know, we probably couldn't have. It's just because I felt like I had a bunch of, I had meetings that intruded in my normal schedule, and then also had trouble getting the stream started this morning because I was going to start at 4 a.m. my time. I was going to move it up a little bit, but you know, I couldn't get the stream connection until about 5:30. So yeah, that didn't work out the way I wanted. So right now I'd say there's a 60% chance that I will do another stream this afternoon my time. So I don't know the exact time. I will put I'll send out a notice in my channel feed. I know you folks in Europe probably will be in bed or close to it. Yeah, if anybody wants to, if I do, in fact, do another stream this afternoon, if you want to drop by all means do so. I'm going to continue on where I left off. And and then tomorrow, like I said, barring hopefully any other schedule disasters or other technical issues, I will plan to be online my normal time, 5 a.m. To 10 a.m. Mountain Time. And tomorrow we're going to try to make more progress with the Raspberry Pi arcade kernel. And yeah, so and that's ARM assembly. So if you have a hankering to watch some really low-level coding, yeah, by all means, let me know. And so anyway, I think that's where I'm going to leave it for this one. And like I say, about a 60% chance that I will stream this afternoon. If you guys are still awake, by all means, I'd love to see you again. And if not, I will see everybody tomorrow morning, hopefully on time. We'll see. This week has not been kind to me on that side. So anyway, I'll talk with you guys later. Thanks a lot. Bye.